Something's not right here. What is this? I got an ERMS 130, so that's supposed to be a 3. Change that real quick. Okay, so now let's take a look at, we can find our inductive reactance here, and we can find our resistance just using Ohm's law. We can find our inductive reactance and resistance of all of the devices here. Let's start with R1. We're just using Ohm's law. Sorry. Okay. So using Ohm's law, we can find R1. We can say the resistance of 1 is the voltage of 1 divided by the amperage of 1. So I've got 28 volts divided by 2. So I end up with 14 ohms for that. And resistor 2, I've got 22 divided by 2. 22 volts divided by 2 amps, so I've got 11 ohms there. So we can say on this scale here, we could say, well, the other number 11 and 14. So we got 25. So we write 25 here, right? We want to be able to find our impedance here. And, there's a variety of ways of doing this, but I'm just doing it in the longest way. Okay, and then XL1. XL1 would be 76 volts divided by 2 amps. So I've got 38 ohms. And then XL2. I got 44 volts divided by 2. So I've got 22 ohms. So now that we've got that, okay, so that's 38 and 22. So I got 60 for my total reactance, inductive reactance. I got 60. So I got 25 there and 60 there, so I can find my impedance, which is going to be 25 squared plus 60 squared. To do that, I get 65 ohms. And we can find our phase angle. We can find our power factor, right? Because our power factor, we know, is our true power over our apparent power. And in this case, I've got 100 watts divided by 260 volt amps, which is 0.38 or 38%. And then if I just do arc cos of 0.38, right? Which is my true power over my apparent power is 0.38. Do arc cos, I get 67.4 degrees. $67.4. Just got to get did our impedance. Put that in there, and our impedance we said was 65. And then the only things left to get are the inductance. So let's take a look. So we'll go, we know XL equals 2 pi FL. So I can go XL 2 pi frequency over L. So L must be equal to XL over 2 pi frequency. So in this case, for L1, I come out to 0.1007 Henries, or 100.7 millihenries. And then L2, so doing the same thing. So 22 divided by 2 pi frequency, I get 0.058 or 58.35 millihenries.